One, the solubility of a substance can be described by the number of grams of solute that can dissolve in 100 grams of a solvent for a certain temperature. So we can track the solubility of the substance A by seeing its solubility versus temperature. We can see, for example, that at 50 degrees, you can dissolve 40 grams of A into 100 grams of water. But if you had a different amount of water, say 200 grams of water, twice as much water, you would be able to dissolve twice as much substance A, so 80 grams into 200 grams. So here's our first question. What is the solubility of substance A at 50 degrees Celsius? All right, so we just said that. It was, for that 50 degree mark, it was 40 grams. So it was 40 grams of A per 100 grams of water at 50 degrees Celsius. And then for the next question, what's the solubility at 30 degrees? So we have our 30 degree mark, and you can dissolve 22 grams of A in 100 grams of water at 30 degrees Celsius. All right, so then the next question is, how many grams of A should precipitate if cooling a saturated solution that contains 100 grams of water and then the maximum amount of solute A from 50 degrees Celsius to 30 degrees Celsius? All right, so initially, if you had 100 grams of water at 50 degrees Celsius, you would be able to dissolve 40 grams of A. But then if you cool down to 30 degrees Celsius, then the solution will only be able to dissolve 22 grams of A in those 100 grams of water. So how many grams of solid A will precipitate out? So you initially could dissolve 40, now you can only dissolve 22. So that leaves 18 grams of A are going to be precipitated as solid. Okay. So in general, for solids, you can dissolve more of them in hot water than in cold water. But with gases, it's actually opposite. You can dissolve more gas in cold water. So maybe you'll see that when you get some cold water out of the tap, there aren't any bubbles. But if you let it warm up, if you add some heat over a couple hours, then that solution can't dissolve as much gas. So now the gas will come out of solution and form bubbles on the side of the container. This is also why various coal power plants and nuclear power plants have to be careful about releasing too much hot water into streams. If you have hot water, you can't dissolve gases like oxygen as well, and so animals might die. So fish struggle in too hot of water. There's not enough oxygen in it. So here's the next question. How many grams of A could dissolve in 50 grams of water at 50 degrees Celsius? All right, so we saw earlier that the solubility of A was 40 grams of A per 100 grams of water when we were at 50 degrees Celsius. So writing that out here, there's 40 grams of A that can dissolve in 100 grams of water. So this is the solubility. But what if we had only 50 grams of water? How many grams of A could dissolve then? Well, you have less water, so you should be able to dissolve less A. You should still have the same ratio of the number of grams of A to number of grams of water before and after. The ratio depends on the temperature, and you're at the same temperature. So because that ratio is equal, we can make this equation. We've set up a proportion. And then we can isolate for the number of grams of A by multiplying both sides of the equation by 50 grams of water. So we can say when we have 50 grams of water, and for every 100 grams of water, you can dissolve 40 grams of A, we should therefore be able to dissolve just 20 grams of A. You can dissolve 20 grams of A into 50 grams of water. Because there's less water than this example, you can dissolve less A than that example. All right. So there's another problem in your homework where you not only need to solve for how much of the solute you could dissolve, but given a ratio like this, you need to solve for the solubility, the number of grams of the solute that can dissolve in 100 grams. Again, you can use a proportion just like in that case.